Okay, so for those that are ready, here's an answer for number one.
No way. You got these. Wait, what? That is so.
That's how I answer the first test.
Like I just said,
Are you talking?
So,
Okay.
good, bad.
What's the average?
Hey.
very last half.
Or else he's stabbed in the chicken.
That's a good question.
You never said
So you're 11%.
Is someone actually doing
Okay, you guys have any questions on number one? Number one. So obviously concept 9, right? It's relating f prime, f double prime. Okay, so number two then. Number two gets a little more complicated numerically and all that stuff. I kind of flowed like down and then to the right and then down and to the right. So over there on the left you can see that I showed that G is indeed continuous. And then I showed that G prime is differentiable.
Why did you get rid of? So
I get the right answer.
Hey, I'd like to answer your question once. So guys, listen up. When you get around to that final answer there where I switched colors for some reason, I clearly divided by 3, and then I square rooted both sides. And keep in mind, when you square root both sides, you have to consider both plus or minus sides of the square root. And I chose minus because of the domain. The domain for that particular function is from -2 to 0. So positive square root of 2/3 does not fit in that domain. But negative square root of 2/3 does fit in that domain.
is it square root of 2 over 3, or is it?
It's square root of 2/3. Yeah, this my square root kind of shrunk a little bit. So I'll put that in parentheses. So that one, hey guys, again, I'd like to address this once. The one that I X'd out there, I wanted to do it to show that you could investigate that, but I X'd it out because it doesn't work here. The reason is that the inverse sine, I'll do my hand motions for you to circle, the inverse sine of -2 pi would be a negative angle. And then a negative number divided by pi would still be a negative number, and the domain for the trig function is only positive numbers. So it doesn't fit within its domain. But it's -2 over pi. Right? So it's going to be down there like the lower quadrants. So you're for sure going to get a negative number or a too large positive number. And so I don't think anything's going to fit there. I didn't actually do the decimals out there, but I think because you're getting a negative number, it's not going to work. Yeah. So that one, it's a nice contrast between 1 and 2 because 1 is very conceptual and very little, if any, arithmetic. Number 2 involves a ton of arithmetic and a lot of detail. So kind of a nice contrast between all the different kinds of things you might see on an AP test. So, yeah. Okay, then here's number 3. And you can tell I used my calculator a bit on number 3 as well.
Oh my gosh,
Please check that out. I've got all my candidates at the table.
Whoa.
And I got my outputs at the table.
What happens with
That's in the 0.
that? Made me so.
H prime, there we go. H prime doesn't exist at 0. Yeah? And that actually ends up being the max, doesn't it? guys know what the
It's
zero
in the
came
negative
from?
because it's technically a fraction.
Yeah, well, it's negative.
But it's negative.
Okay.
Remember, all of your candidates are endpoints, critical numbers. I couldn't understand endpoints are obviously -1 and 1. So 4/5 to the 5/3 is obviously
This quiz has a zero.
Why would 0 be a critical number? Why would x equals 0 be a critical number? So you said if you put 0 into the thing, which equation? Okay, yeah, if you put 0 in the original equation, that means y equals 0. But that's not what a critical number is. A critical number is a place where h prime is 0, or where h prime
That's what I did.
doesn't exist. 0 to -3 this is really a denominator. Isn't it? If it's 0 in the denominator, there's your unit, right? You gotta think about that. That won't always be, it can happen. You gotta just take it all just like Hey, how we doing with 3? Questions on 3? Are you guys? Yeah, I was gonna say, are you all okay with this? Right? Oh, come on, computer. Here we go. You okay with this? I highlighted it in gray. Like, do you know where that came from?
I do not.
Say again?
Because h prime of x doesn't exist there.
Why not?
Because if there's a negative to the exponent of a negative, then that means it'd be in the denominator.
There we go.
X is 0.
And if x is 0, it'd be a 0 in the denominator. Yeah, so h prime doesn't exist when x is 0 because of the 0 in the denominator thing, like Dana said. That ends up being the maximum. So, again, any of these absolute minimums or maximums type questions, you might have a chance to graph some of these. Like this one, you could definitely graph, and you could actually see where the critical points are and the end points, which one's higher or lower. Here, the left end point is the min, and the first critical number is max. Should be able to see that showing up on a graph. Could be a good thing to see.
How could you have a max there if it doesn't exist?
So you want to be really careful. You just use the word it to refer to something that I'm not sure.
H double.
H of x definitely exists at 0. In fact, h of 0 is 0. H prime doesn't exist. So what does that mean? If h of 0 does exist, and we have a continuous graph, but h prime doesn't exist, you've got a sharp point. So we've got one of these guys going on right there at 0, 0. So you just want to be really careful with not overgeneralizing and saying, hey, it doesn't exist, therefore, blah. Be careful, what does it actually mean, right? If it's h prime or h or h double prime, that's totally different meanings. Cool. Other questions? Okay, cool. Did you see the graph?
Yes, I did.
Does that make sense? Okay. All right, so let's keep talking about maximums and minimums. This is a nice one to start off with, knowing what we just did. So number 1 says find the critical numbers for f of x. And then we're supposed to apply the first derivative test and identify any relative minimums or maximums. And I know for you guys, it's been like 3 or 4 days since we talked about this, at least. The other class had the luxury of it only having been a couple of days, so I don't know how rusty you are, because you only saw this once before. At least see if you can find critical numbers, and if we need to kind of review what the first derivative test is, we can for sure do that, but see how far you can get. The critical numbers are places where?
Critical number.
No. F prime is what?
What's 2/3 minus 1?
So it might be wise to find F prime.
Yeah.
Since you don't have it, do a little bit of work. Yep, there you go.
You know that there's one.
Figure out what F prime is. Remember that critical numbers are places where F prime. So we probably would want to know what F prime is. We don't yet.
But we don't have the n, right?
So that's why we're looking for relative extrema. So think of it like this. Relative extrema is just a relatively high point. For example, didn't you have to walk upstairs to get up to the third floor? Does that mean you want to just climb the doesn't mean that you've reached a relatively high point? You go up the stairs and then down the stairs. It's the same as like with those hills down there. You can walk up to the top of those and then you can walk down hillsides. Just because you go from up to down doesn't mean that you've reached the highest point on earth. But you have reached a relatively high point, right?
And this morning.
Hey, I wrote F prime up there on the screen. We can compare that at least, right? Make sure we have the same F prime.
Oh, like 0, -4, not 2.
I know,
I thought
right?
you were saying like -4 was other point.
That's a lot.
Maybe think about the x to the negative 1/3. Think about flipping that down and making 2 over 3x to the 1/3. You're analyzing for negative x to the
X to negative 1. Maybe a 3. So now we prove from the relative.
I forget what was
Okay, hey guys, let's, gentlemen, others, everybody, yes, okay. Let's look at this. We've got the F prime right here. I always do this first because I feel like this is easy to forget. I always ask myself, are there any x values that would make F prime not exist? You see any? All right, so same thing as we just had really in our warm-up. I would say that F prime does not exist at x equals 0. That means 0 is one of my relative extrema candidates, right? But then we also have to consider where F prime equals 0. So I'll also set this whole thing equal to 0. There's a number of things we could do here. Here's one of them. Couldn't you do this? 2 over 3x to the 1/3 equals 0. And as I walked around, I noticed a lot of folks kind of staring at something like that and just thinking, I don't know where to go from here, right? So let me ask you the question in this way. Can you think of any numbers I could just plug in for x that would make that left side 0? So if I plug in a 0 there, don't I get 2 over 0, which is D and E, which we already covered right here. So we already have that critical point. So can you think of any numbers besides 0 that might give us a hint about how this equation works? There's no numbers that work, right? Let me put it to you like this. When you've got a fraction like we do on the left, what is the only part of the fraction that could make the whole fraction have a value of 0? The numerator, right? If the numerator is 0 and the denominator is something other than 0, then the whole fraction has a value of 0, right? Well, the numerator is 2. And there's nothing we can do about that. So I would say that this is never true, right? This never equals 0. And so we're not going to get an x value out of that. So this is one of those rare cases where the only critical number comes from where f prime doesn't exist. There's no places where f prime is 0. A lot of times we'll get f prime equaling 0 and get some critical numbers from that. Here, we just don't. Okay, so if we're going to apply the first derivative test to identify relative extrema, I feel like a sign chart is a nice place to start. This is going to be a pretty small sign chart. The only candidate is 0. I need to pick out some numbers to plug in to test out both of those intervals. So I've got the gray interval and I've got the yellow interval. what number would you plug in for the gray? -1 makes a lot of sense. So I'd say f prime of -1. F prime of -1 would equal what? -2/3. You're right. Good job. And then over here, f prime of, did you guys go with 1? What would that equal? 2/3. So f prime is going from negative to positive. Okay, so the sign chart is nice, but it's not a justification. It's not an explanation, which you will very frequently be asked to do. And so I don't know if you had a chance to do this. I'll give you an example of what it could be. I'll say f prime of 0 does not exist, and f prime changes from negative to positive at x equals 0. Therefore, what's my conclusion? F has a minimum. The other way, yep. Therefore, f has a relative min at x equals 0. So remember the reasoning here is that since f prime describes the slope of f, really what this is saying is the slope of f goes from negative to positive. Therefore, f goes from decreasing to increasing, which indicates a relatively low point on this graph. Okay. And by the way, this is the graph of this is the old kindergarten bird shifted down 4. It looks something like that. Or maybe it should be the high school bird. I don't know.
Just the bird.
Just, yeah, it's how we draw birds, right? Yeah, got it. Okay, so give you a chance to reflect. Think about what you did. Maybe you completed this really well. Maybe you got stuck in there somewhere. I don't know. Give me follow-ups, any questions I can answer for you. All right.
Is it the relative mins are always if it goes only if it goes from negative to positive?
You just use the word it. Careful.
Oh, I see it.
Dun, dun,
F
dun.
prime is positive to negative. and-
Negative to positive.
No, I just
Okay.
If-
And then the max would be when F prime is from positive.
Yep, that's a relative max. Yep. Okay, so you'll see number 2 is a similar question. It's worded very similarly, but the information given to you is quite different. I'll read it out loud. It says, given the graph of G prime, find all relative minima and maxima of G, and work on your justifications. Practice writing it down. Don't say it in your head. Don't just say it out loud if you so choose. Try to write it down. So give it a shot. That's a graph of G prime. Find the relative extrema of G.
Yeah, that is what I got.
Endpoints aren't necessarily correct.
If this was a graph of G, it would be
This is G prime.
if it was G double,
I don't have
then
to
it would be
run
G.
my
We're talking about
So I'm not intending to keep you. So critical
My eyes
point
can't
for
focus
G
when
prime
you're like, 'cause I can see far away.
or doesn't exist, right? And I would say right there, it appears at least. G prime of 4 is 0. This one's not
It's like.
yeah, so I didn't ask you to do that. I was just, this was like for the, right, so, yeah, so it actually equals 4, G prime doesn't, it doesn't change much.
Dang, Joey. Shots fired, bruh.
What G has, what graphical feature G has, it
Where you going? PT.
Nope. G double prime.
Today with my old PT. 5:45. Perfect. I don't want to come late. Oh, stop. You won't be late. Sharing excuses. That kid. You are actually don't. I told her you don't want to hang out. Are you out of no, I just have a lot of stuff this weekend. She just like refuses to leave my house.
Yeah, I'm just trying to get you to like make all
I'm like, hey, like, can you come over for like an hour and like hang out and talk and like see you? 4 hours later, she leaves and my dad's like, did you do any homework? No. What do you expect? And then I get in trouble for it. So.
She goes for
Yeah, she gets two buses on paid nights.
You guys know? Inflection point. I'm just trying to get you to make more. Like, you're obviously making.
Yeah, Reed. That mentality, maybe you should go to CSU. Date rape. Reed's big and the date rape.
No, you're good. Go ahead.
Alright, how are we doing? Looks like we're doing pretty good. Hey, let's do a pretend. Let's do a pretend. Let's say that I am one of your students, and this was a quiz question, and I wrote this answer to this question. I wrote x equals -2 is a min. X equals +2 is a max. X equals 4 is a min. What feedback would you have for me other than wrong?
You thought you were looking at.
Oh, Joey just said, hey, you should listen. Shh. Hey, Joey just said it well. He said, you're confusing the graph of G with G prime, right? Like, if I thought this was a graph of G, I'd be right. Like, if this was a graph of G, I'd be 100% correct. You guys with me? Are you with me? If this was G, I'd be correct. But it's not a graph of G. It's a graph of G prime. This is a cautionary tale. I've seen plenty of capable students over the years that know better that make that sort of mistake, right? Hopefully, you'll quickly get out of that if you do. Would you guys be okay if we said that G has relative minimum at x equals 1? Does that make more sense? Because G prime of 1 equals 0, and G prime changes from what to what? Negative to positive. We'll get to that in a second, Anna. That's a real good question. Then we'd say G has a relative max at x equals -4 because G prime of -4 equals 0 and G prime changes from positive to negative there. Okay. So are you guys okay with those 2 points being the min and the max, the relative min and max? Okay. So Anna just asked a question that I think really applies to all of us. I think this is what you said. What if we didn't put this or that?
Because I totally didn't.
Right? So remember that relative extrema only happen at critical points. That's the only place they happen. not endpoints, not some other point. It's only at critical points. And so in order for you to even have a particular place, even be a candidate for a relative min or max, it's got to be a critical point. You have to state that somewhere in there, right? So if you said x equals 1 is a critical point, and g prime goes from negative to positive there, then that would work. But you've got to indicate that you've got a critical point, wherever it is you have a critical point. This also, the other thing here is this kind of, in our own little way of doing things, implies continuity, which is really what this is about. Because if g prime, think about it, if g prime goes from positive to negative, but g is not continuous, couldn't you have one of these? And there's not a relative minimum there, right? So really the requirement for the first derivative test is continuity. That's the condition for it. And we just customarily don't go there. We usually just say, hey, we got to have a critical point and see the sign change pattern in g prime, and that's good enough for us to use. So the short answer to your question, Anna, is yeah, you want to have that in there for sure somewhere, right? Maybe it was part A. Like sometimes the questions are in part A, list all the critical numbers. So you list them out and you say, hey, that's where g prime or whatever is 0. And then part B would be, okay, and then tell us at those critical points you have relative min or max. Well, maybe then you don't need to because in part A you already told me. But if it's just this, you really do have to say the whole thing.
Is there a possibility that there's more than one relative min or max?
Sure, you could have 75 of them. Because all they are is just relatively high points. Colorado is full of relative mins and maxes, right? The mountains. Every single mountain and every single little ridge and valley you can climb up or down into, they're all relative mins or maxes, right? None of them are the highest in the world, right? But they're all relatively high or relatively low.
Like a sine function.
Yeah. Yeah, every time you go up or down, it's a relative min or max. Yeah. Anybody else? Okay, last one. Please try 3. It's a good one.
We're just talking about the sine and cosine.
Every time sine is removed.
That's actually a way to kind of prove this derivative of cosine is negative sine, zero sine, zero sine.
And that's why it's like shifted.
Yeah, they're up by 90 degrees. Or 5 or 4, or 5 or 2.
That's why I like
You can actually see how, like when sine goes from negative to positive, cosine is relative in. Like every one of those is over and over and over again. Okay, we're trying number 3. This obviously is presented in a third way. So far you've seen analytical presentation, you've seen a graphical, this is a table. You've seen 3 different ways that this could be presented.
Wait, no, it's
You say it's
you.
your
I don't think you want to answer
You'll find it at just x g of 2. So g of 2 is g prime of 2.
You don't find that.
Is there a 0? So each prime of x equals
So g prime of 2.
That's important, right? Because that's not the case, then we have a problem.
it's not 0? Is h prime
H prime of 2,
H prime of 2
then it wouldn't automatically just be either? So it wouldn't be a critical point, right?
But h prime of 2
It is, right? So I'm saying, like, if you need to actually confirm that, right? Because if you got H prime of 2,
Right.
yeah, if you find H prime of 2 and it's
F prime of 3 is 0 times
the
negative.
answer's automatically either.
Okay. 0. Oh, then you have to do a sign.
Yeah.
Sign
this is at F prime.
Right?
Critical point was when x is 2.
Oh, because X is, I don't like
H prime of 1.
it. And that's why the one, oh. Wait, do we do that 2 or 0?
So I know, right? That's 4 times G prime.
How do you know if it's
Zero. H prime of 2 is 0.
You do 1?
What's H prime?
I not like these first ones.
So H of 1 equals F of V.
So
V of 1 is 2. F of 1 equals F of 2. F of 2 equals 2. Does not
every second.
What's going on?
H prime of 1. F prime of 1 is not. Oh, it's F prime. Yeah, you're right. G prime of 3 is 2. So it's negative 1.
So H prime of 2 is 0, that's me saying that people like total, and then I say,
Oh, I did the same thing. Yeah.
Therefore, H prime of 2 is 0.
Yeah. Yeah. And then you plug it in.
Oh, sine prime.
Yeah, but we saw the critical number.
How do you find negative?
Yes.
relocate my left hand.
Oh, no, guys, we're plugging it in.
So x equals 2 then.
So this one we have to plug left 0. So now we have to.
Hey, why don't I show you an answer here, and we'll have some time to discuss if you want.
I think we're getting some.
All right, so
Oh, yeah. That's where we went wrong.
Darn it.
I did.
Oh. I did it right, actually. Yo.
Let's go, Mitch.
Mitch, you're so smart.
I want this.
That might clarify, because otherwise it is pretty intimidating looking, just pile of numbers and symbols and stuff.
is this explanation good? I said left to see. H prime of 2 is 0, and H is
Please ask if maybe you have an explanation that sounds pretty good, it's not just like that, you're curious. Let's talk. Maybe you guys noticed that in the little explanation I said something about H only having one horizontal tangent. You understand why that was important for me to say? Why would it be so important for you to know that H only has just a one horizontal tangent? One critical point. Isn't it because of the way the table is set up? Like you basically have x values of 1, 2, and 3. Just because h prime of 2 is 0, like what could happen between x equals 1 and x equals 2? A lot of stuff, right? There could be zillions of ups and downs in between there. We don't know exactly what that would look like too, but if you know that there's one horizontal tangent, then you know that everything to the left will have the same characteristic, and everything to the right will have the same characteristic, therefore not this going on. Anyway, there's that. So, any follow-ups, any questions? All right, so let me think here. I think two things. Number one, tomorrow built into our warm-up, I have like test debrief. So like kind of the first little, instead of having 3 warm-up questions, we'll just have 1. And so like 2 of the warm-up questions will be test debrief time. So we'll have that. We're going to continue on like this whole unit, really for the rest of the time is about maximums and minimums. And so we'll continue to process those and look at different techniques and contexts and stuff. We'll bring the water tank back. All right, have a good rest of your day. Thank you.